Triton is well known to be Neptune's biggest moon. What if, however, it wasn't always that way? Would you believe me if I said that Triton was once a dwarf planet? The size of this enormous Neptune moon has confounded scientists ever since its discovery. Triton is extremely odd because it is coated in a thick coating of ice that might possibly serve as a habitat for life in the waters below it. According to a group of NASA researchers, there is a very good likelihood that Triton was once a minor planet that Neptune abducted and transformed into the extremely unusual moon it is today. What, though, prompted scientists to raise that possibility? They needed an explanation for its anomalies, such as its odd orbital direction and high reflectivity. Join me in this video to learn the amazing secrets of this extremely far-off planet, as well as the answers to these questions and more. Triton is one of our solar system's most enigmatic moons and is the largest and most massive of Neptune's moons. Triton's diameter is 2,706 kilometers, making it only slightly smaller, by around 800 kilometers than the moon that orbits the Earth. It is the seventh largest moon orbiting our solar, weighing 10 to the power of 22 kilograms. The discovery of Neptune and its moon Triton is a pretty strange one. That's crazy, isn't it, that it was watched for 2 centuries before it was identified as a planet. Let's go back in time to the period of Neptune's discovery. Neptune was a brand new planet that was discovered in the past in 1846. Galileo Galilei had discovered its existence very early in 1612 when he used a crude telescope to study Jupiter and saw a weird point close to it. Neptune, which had been in the same place at the time, was later found to be this. As soon as astronomers became aware of a problem with Uranus' orbit, they began to suspect that an undiscovered planet must be behind the problem. Triton, Neptune's largest moon, was found by English astronomer William Lassell just 17 days after Neptune was officially identified. Interesting fact, it wasn't until 1949, when Nereid, Neptune's second moon, was discovered, that the moon received its name. It was given that name in honor of a merman from Greek mythology who was the son of Poseidon. Do you know what distinguishes dwarf planets from the planets we are familiar with, as I indicated when I first brought them up? This is a simple explanation of what a dwarf planet is. A dwarf planet is defined by the International Astronomical Union as an object that orbits the Sun, is sufficiently massive to be approximately spherical in shape, has not cleared the space around its orbit, and is not a moon. So let's go over every argument in favor of Triton being a former dwarf planet and a recent arrival in the solar system rather than a moon that developed around Neptune. Keep an eye out because this could totally blow your head. Number 1. Retrograde motion. In the past, people believed that the universe functioned like a giant clock that always kept the same time. Yet as of late, we've learned that a lot of things don't actually operate that way. For instance, the sideways tilted Uranus or all the comets and asteroids that orbit our solar system in various directions. The most intriguing of all is Triton, which orbits Neptune in the opposite direction. In 1989, Voyager 2 reached the Neptune system and found Triton in a retrograde orbit. Watch our movie to learn more about Voyager 2, the only spacecraft to closely observe all 4 large planets in the solar system. None of the moons in the outer solar system have a reputation for being particularly weird than Triton. Its retrograde orbit sets it apart as the solar system's 7th largest moon. When a planet appears to be moving backwards in the sky from Earth, this is known as retrograde motion. Due to our vantage point, this happens while the planet is orbiting at a somewhat constant speed. To put it another way, picture staring up at the sky at night and noticing different stars and planets in various places of the sky every night. One of the planets will occasionally appear to stop moving ahead for a little period of time, then resume moving forward. Retrograde motion is what causes the planet to appear to be making a large loop in the sky. This implies that Triton was most likely not created in orbit around Neptune, but rather could have arrived there forcibly as a visitor from another part of the cosmos. Triton travels in an odd manner for reasons that scientists are still trying to understand. Some believe that it moved differently because something struck it long ago and altered its trajectory, but the math doesn't add up. Triton would have been torn to pieces if something had the power to alter the way it moves. It is hypothesized that Triton, like Pluto, was formerly an autonomous icy planetesimal in the outer solar system. They are similar in terms of size, density, and surface makeup. Yet, it is speculated that Triton was sort of kidnapped by Neptune early in its trip when it got too close to the enormous planet. It's as though Triton once got too close to Neptune, who was quite strong, and grabbed a planet that it was friends with. This caused Triton to slow down so that it could start interacting with Neptune. Triton might have collided with Neptune or been sent flying like a boomerang if it hadn't been for Neptune's assistance. The precise fate and present location of Triton's ex-partner are unknown, but scientists hypothesize that it has likely been ejected out of the solar system as a result of its crossover with the outer planets. Astronomers have noticed an increase in the number of binary planetoids in the asteroid and Kuiper belts, and scientists hypothesize that other planets may have similarly captured moons. There are not many restrictions on the kind of binary planet encounter that resulted in Triton's capture, and these kinds of objects have probably been existing for many billions of years. The computer model illustrating how binaries may have contributed to the expansion of the solar system's moon population has garnered praise from planetary experts. The likelihood of Triton colliding with one system is extremely unlikely, and the model supports the exciting finding that there is a critical mass of hundreds to thousands of Pluto-like dwarf planets. Number 2. Exceptionally high albedo. As one of the brightest celestial bodies in the solar system, Triton stands out. Triton reflects 60 to 95% of the sunlight that comes into contact with it thanks to its extraordinarily high albedo, which is a measure of how much light a surface reflects. Our moon, in contrast, barely reflects 11% of the light that enters it. Given its great separation from the sun, this is extremely impressive, and it hasn't altered much since the first sightings of it. Triton is highly reflective because, unlike other moons, it is most likely made of ices of nitrogen, methane, and carbon dioxide. Triton may be a Kuiper belt object, like Pluto and other trans-Neptunian objects that have been or may have been drawn towards the gravity of the planet, according to this composition. Triton's exceptionally high albedo may provide some insight into certain enduring concerns about the formation of planets. Scientists can learn more about the forces and processes that shape the solar system by examining the albedo of different moons and other planetary entities. For instance, planetary formation activities that took place in the outer solar system are assumed to be the cause of Triton's relatively high albedo. Triton is a perfect option for planetary scientists to explore due to its high albedo. Due to its high reflectivity, it is considerably simpler to view and measure than other moons, which makes it a prime candidate for solar system research. Number 3. The makeup and activity of the surface. Similar to many moons in the outer solar system, Triton is thought to have an icy surface and a rocky core. Yet, it stands out because it is one of the few that is geologically active, which results in the phenomenon of cryovolcanism, where geysers erupt through the surface and give the moon a distinctive, psychedelic appearance. Gas drag, which can happen when a moon travels through the atmosphere of its host planet, may have changed Triton's orbit throughout time. Triton's orbit would have become very erratic following the close encounter with Neptune, whether because to a collision or gas drag. Its orbit's eccentricity did, however, gradually reduce due to tidal interactions between Triton and Neptune, leading to its current almost circular orbit. It is assumed that more than 1 billion years elapsed between Triton's capture and the time it arrived in its present, circular orbit. Triton would have completely melted at this time due to the powerful tidal forces it was subjected to. The denser components of this molten material would have sunk to the moon's core, while the lighter components would have risen to the surface. Triton developed a thick surface layer made mostly of water ice because its surface cooled more quickly than its core. Cracks in the external ice covering were created as the water underneath the surface froze and expanded. As no other component of the moon's subsurface can expand when frozen, the shattered surface of Triton seen in the Voyager photos is proof that the moon contains water ice. To sum up, Triton's peculiar orbit, peculiar albedo, and extremely circular orbit offer insight into the dynamics of the outer solar system and its interaction with Neptune. That concludes our discussion of Triton's intriguing past. Triton is a fascinating reminder that there is still a lot to learn about our enigmatic cosmos, from its mystery origin to its retrograde orbit. We can only speculate as to what other mysteries are just waiting to be discovered in the universe, and we can only hope that science will soon solve them. Until then, sit back, relax, and admire the beauty of our solar system. Thank you for watching, and see you later.